Papa Bale. Welcome to the channel. I'm setting up a second Bedini SSG. Alright, we're just going to get the wires in there real quick. Alright, those wires are in. And I'm switching the circuits because I think the switch is giving out it finally. Don't know what happened, but it's falling apart, the switch is. So I'm going to use one of the ones without a switch. Solid. See? Like I push it back in, it says hit or miss when I do that. So it's not. Oh, I want to get the transistor though. That's a good one. All right. Oh, I want my screwdriver, man. This one works pretty good though.
Mm-hmm.
Just tiny. All right. So this one is the end, the black one, which goes in the black hole. Screw it in, nice and tight. And then the red, this is the beginning.
Thank you for the like. Welcome in.
Thank you. Hello. There we go. We got the drive set up. Now, this is a 30 gauge trigger coil. I'm going to put the negative in first. Oh, it did not go in, and I can't barely see. So we're going to try this again, and hopefully we're a little bit more straight with it. Yeah, there we go. All right, that one's in. We'll take our positive 30 gauge.
Ruben asks, what are we making?
This is a pulse motor. It's going to be going at 180 degree coils with 120 degree magnets. Don't know if I'm going to make it a relay or not. Right now it's going to be running parallel. 12 volts. is a Bedini SSG. From kenergy.store. And bam, we are in. Alright. Let's get this up here like this. Alright, moment of truth factor. Don't know what's going to happen. It might stall out.
Welcome in, Kebab Guta. Thanks for dropping by.
Oh, we're good. Looks like we're good.
Ruben, this is for experimentation.
Yeah,
Testing
we're good.
data, testing inputs and outputs.
Alright, I gotta do the bearing. Alright, we're good. Yes. We can do a relay now if we would like to. The only problem is this is with the negative spike and that is without.
Okay.
This is SSG with gen mode and that's SSG without gen mode. That's just how the cookie crumbles right now. Alright, so let's turn this one on. Let's see if we can get a nice dual drive going here.
So both of these coils have power supplies hooked in.
Yes.
All right. So
and
there's
their own
one.
circuitry. We'll do it 50-50. We'll do 6 here and 6 over here.
Yep, those are the magnets. The squares. And then the current through the circuits and the coils.
That's a pretty nice air gap too. I have to shrink that a little bit. Jigs.
Sorry, buddy.
So I think that's great movement for 6 volts.
Cross country skiing in the house. Welcome in.
All right. So this is actually charging this battery right here. When I said this, I meant this coil, the circuit, this power supply is charging this battery. I think it's, God, it's so smooth. And I think that can go relay. I think that can do a relay because it's on and off at the correct times. I just don't know if it's on and off long enough to do it.
We got a question. What's controlling the frequency for the coils?
The trigger coil and the magnets on the rotor. I have a signal generator. It's not hooked up currently. I was going to hook it up to this coil though. It's a Litz coil. It's a 100 strands of 38 gauge.
Twisted up into the...
Yep, and twisted. See this one's drawing 200 milliamps and the one over there isn't drawing any.
probably below 50.
Yeah, well, below 100. Yeah. It's definitely drawing some, it's always going to have some sort of value, but it's below 100 milliamps. So that's awesome.
Thank you for the like. We appreciate y'all. Like and subscribe if you like the DIY kind of content. Let us know if you have any questions.
All right, let me go to a 9-volt battery here. Well, that doesn't sound right, does it?
Yeah, that's making sound.
Is it shaking?
I don't know, man.
Yeah, it's just shaking. It's all right. We'll slow it down.
Ah, I got it.
That's powerful. It's amazing. And there's something not sturdy right now about the rotor that I.
Boss 221 asks, were you able to check out those pots on the website?
No, I like you suggested where to post. I didn't exactly tell you where to post. I couldn't find where you dropped the link at. Is it on the Discord or my email? That's better. All right. See, I want to show you something real quick. When it's lined up with this coil, the magnet, there's an open space on this coil. So I could see how that could work in a relay. And then when that one is on, this one is off. On, off, on, off. You see how that works? I just don't know if it's on and off for a sufficient amount of time. I think it would be. I mean, that magnet is pretty close in proximity to the coil. And since it's being run on a trigger coil, I mean, it could trigger at the wrong time. But it looks to me like it would work, but that's not going to be a thing, you know?
Boss said your YouTube channel community button.
Oh, on my post page? Awesome. Awesome, man. I'll check it out.
Then have you got a rough RPM reading?
For this? Not yet. Let me get my
Tachometer.
my tack meter. My tachometer, yeah. We found it. And it's awesome. Just remember to divide this number by 3. Whoever gets there first gets a cookie.
Mm.
And we'll do 6. We're just gonna do 6 volts. Barely any output for Bedini. Let's turn that one up to 6 too. All right. Oh, that's so cool, man. Because I've been trying to get this one to work, but all my transistors are blown except the one that's in the other slot. So I'm like, shoot. They just came today. One package. You get 5 shots and that's it. So it's still picking up speed. Let's see what it's at.
Welcome in, Patricia.
Hello, hello. 1800, 1900. 2000 divided by 3.
Right around 700, 650.
Yeah, you're still going.
Oh yeah, that'd be 700 right there.
22. All right.
If it gets up to 24, that'd be 800. There we go.
24.
800. And then 27 would be 900.
All right. You might get up to 900 RPMs at 6 volts in, man. That's pretty good, I think. It is drawing 200 milliamps on this side and 0 on that side. The coil configuration is a lot different though, so. And it's got a different core. They both got cores. Okay, we're getting up at speed where it's starting to shake everything. I think 2900 is where that happens. That's 900 or 27. I mean.
So that would be 900 RPM.
Yeah, 900. All right, it'll make it there. But I'm gonna cut it back.
Drop us a like and subscribe. Let us know if you have any comments.
I was playing around with the iron dust yesterday. We're gonna get a shot of that because I really do want to do that with my brother taking a shot of it. But that bottom bearing popped out, and it started to wobble really, really bad. So I don't know how much of the actual packing got stripped on the bottom. But it does look like it is wobbling a little bit when I look at it. Huh. Well, I don't know.
Thank you for the like. Appreciate it. The faster you get it to spin, presumably the faster you get it to spin, the more it picks up on really minor bumps and instabilities.
That's what I've come to notice, that it picks up on it more so than
Yeah, if
less
it
so.
doesn't look fun fixing the wobble. Yeah.
I mean, I have another rotor just like that one. That might be a little bit more stable, but I'd have to transfer the maglev donut and the 3 magnets over to it. It's not a big deal, but we'll just run one coil this time. Because we're just looking at the 0 point field and the north and south fields and how large they are, how much space they take up. So you can see, like, it loops around, and in where the dust isn't moving is inside of that loop. You see what I'm saying?
And yeah, it is. We got a lever right here.
See, like that spot right over the magnets is where that 0 point energy is. Where it's not moving.
Mm-hmm. That's wild.
That is so fun, dude. Anybody got any ideas on what I should do? Like how, maybe I'm gonna put it up on the pole a little bit. And we'll see how high we can get a response from the dust. Oh, it's working up here. It's not moving, but it's right there. There it is. That's pretty high up there. Man, that's strong. That is. Look at that. That's definitely not going in any general direction. Not really. All that power is just kind of jumping up and
Oops.
down.
Wow.
So cool. All right, let me get the green paper real quick. After I put this powder away. Wow, that is going really fast for that coil. That's pretty awesome. Glad I invested in the transistors.
Hey everybody, thanks for dropping in. This is Papa Bale's Pulse Motors. Like and subscribe. Let us know if you have any questions.
So I spelt a little bit of it. Pick that up with a magnet. Alright. Green paper. And we're gonna see.
Thanks, Rory.
Look at the back end over here.
Oh wow.
That is coming off the back end of my coil. Over here where my thumb is. Look at that imprint on the paper. That is freaking amazing. Or was it already there? Could it have been already there? Yeah, it could have been.
Now lift it up.
Yeah.
Or turn it sideways.
You see the core has definitely got some energy around it.
It's called Ferro paper? What is this called?
I'm not sure. Electromagnetic indication paper. It indicates where the magnets are. Not north or south, just magnetic. Oh man, it's okay. So it's not coming from the coil.
Okay. That would have been sweet.
Yeah, I'm like, wow, man, that's it. That's what we all been looking for, man. That's it. Forever, man. Everybody's been looking at it forever, and there it is. No, I'm just kidding. That's funny though. That but that core is definitely leaving an impact. All right.
Hey everybody, welcome in. Thanks for dropping by. Let's see if we can get up to 100 people watching. Like and subscribe. Let us know if you have any questions.
Any imprint on the other side? No.
I don't see anything active, I think.
Yeah, it's like only the permanent magnets leave. Let's try it in the front here.
Nice, 113 people watching. Let's see if we can get it up to 10 likes. Welcome in, Slim.
See anything up there, bro? Hello, hello.
Yeah, a little bit right at the level of the rotor.
Right in the middle,
Yep.
and it's moving with the paper. Yeah,
I think so.
I kind of see it too, a
Yeah.
little bit. Yeah, it looks kind of like a light, like a light hitting off a wall or something. Yeah. Okay. You can kind of see it all right here. Or moving it up and down. It's solid white, kind of lighter green.
Mm-hmm.
So what does that mean? That it's only occurring in that one like strip like this, like right where the core's at, across that horizon.
That it's focused.
It is focused and it's in the right spot. It's just you would expect the energy to be the shape of the coil, not the shape of the magnets in the core. Because I think what we got here is the magnets reacting to the core and the material around that interaction is all that's registering an effect. Oh,
Careful.
yeah, my bad. I've been stepping on that the whole time, I think. All right, so
Hey everybody, welcome in. Thank you for dropping by. Like and subscribe. Let us know if you have any questions.
yeah, woo! 2 for the price of 2.
2 for the price of 2.
See, but what we could do, since this is, I'm only saying this is because then it'll be equal. We hook them up through the cap banks. We try to do a relay that way, through the cap banks, and we hook them up through there to get rid of the negative spike on this one, because that one won't generate a negative spike. And then it'll be even, and then it'll be equal. I think that's what we're going to do. So I got that cap bank, and then I got this one under here. And this one will charge that battery, and this one will charge this battery. Now the only thing is that I have to do it with a 120 or a 180. But if I do it with a 180, then I got to move the coils to 90 degrees.
And no, that's everything's eyeballed, so nothing's at the exact same height. And there's a bow on the table.
Yeah, man, it's ghetto fabulous.
Welcome in. We are true DIYs. Yes. And bootstrapping it.
Yeah, I do have a 3D printer, so I don't really have an excuse.
Right.
Except that, you know, I've only just started learning that language, and I think I do a pretty okay job with the tools that I use. But I can't make screws, I can't make bolts, I can't, you know, do things like that We know that all that stuff would be useful. Make nylon bolts. That'd be useful. Right on.
Hey, Matthew, thank you for dropping in.
Hey.
What do we got going on here?
All right. Right now we're looking at a dual drive Bedini SSG pulse motor. And we're gonna cut it until we get all of our meters up and running. But we're running this Bedini SSG on this trifilar, and it's charging this battery, and then that Bedini, this Bedini SSG is being run on this power supply, 6 volts, and it's charging this battery. It's a 20 gauge coil, 730 turns of 20 gauge. But it's a trifilar coil, so it also has 730 turns of 20 gauge and 30 gauge. 30 gauge is a trigger. That one has a 32 gauge trigger. That one's like in between 500 and 300 turns over there, that one. It's got a drive of 18 gauge or 1 millimeter. It's got 20 gauge trifilar, and then, like I said, the 32 gauge trigger. And this motor's output, or no, this motor was hooked up to the other coil, so that's why it's stopping. Okay, but with the dual drive, I'm able to run a relay. And I think we're going to go, yeah, it's going to be all right. We're going to go, like I said, we're going to start using the batteries for power, though. That's what the whole relay situation is about. We're going to try and make that life last a lot longer than it normally would via relay.
Welcome in, Yanni.
Hey, Yanni, what's up?
And Matthew says he'd love to collaborate.
Nice.
He has efficiency ideas.
Cool. I just updated my Discord information, and that should be good to get straight. You can send me information through that. We can talk on Discord.
Thank you for the like.
All right, so in this relay, this battery, I believe, will be running that one, and that will be running this one. That will be running that battery will run this coil, and this battery will run that coil. This coil will charge this battery, and that coil will charge that battery. And it should happen on and off. And we'll take a look at the rotor here. So when this coil's on, that coil's off. And when that coil's on, this coil's off. And that's important. All right. Should I hook that up now?
Can you please send me your Discord URL, please?
Yeah, it's on
The account page?
Yeah, it's on the account page.
The about section of the account page.
Yeah, the about section. And if you click on show me your email, my email's right there too. You can just send it to me through the email if you want. And I'll get you if it's not updated, because I just did it yesterday. So it should be good. Yeah, I wish I had a pocket laptop, you know? Could just do this thing on the fly. That one wants to move.
Mm-hmm.
See, so the energy's going through the system to the secondary motor, and this one's not on at all, like moving anyway. So that's cool to note. And like I said earlier, the faster this one, the faster that screw like connects, the faster this one will go.
Yanni found it. Cool.
Nice.
Yeah, not everybody can navigate to the about section. I think it's different on different devices, but
Yeah,
it's
the
always
device
there.
might matter,
Keep
for
looking.
sure. Yeah, I got over 4 million views.
Congrats.
Thank you.
Yeah.
People, that's awesome.
We should do a thank you live.
Yeah. And it's not like I got congratulated, I just noticed it. I was like, that's awesome. I mean, I do have a strong thread on Pulse Motors. It's got over 2,700 videos in it.
Mm-hmm.
Shorts, regular size videos. I try to like make a video documentary of all of what I'm doing.
Thank you for the likes.
Yeah.
Let's see if we can get the likes up to 10. Appreciate y'all. Let us know if you have any questions.
See, now this is a 12-volt system, and both of these circuits are 12-volt circuits, but that's going really fast right now. If I put it up to 12, there's no guarantee that's going to hold together. Like, so I'm holding off on that. Especially on the dual drive, I got to get some sort of wall up here to make me feel safer. Because this is just 6 volts, man. It's
Cooking.
Yeah, where did my sac meter go? There it is.
Thank you for the likes. We just need 2 more to get to 10. Appreciate you guys.
So it's just under 900.
Okay. At 6 volts. It was 9 last time.
Yeah, that's amazing.
Mm-hmm.
I think I might have to do something with the rotor, because that seems a little shaky to me. Alright, I'm going to switch it up to the 9 magnet rotor real fast, and that's going to be like our the extent of our switcheroos today. And as long as it's moving, and especially if it's moving at that rate, like 900 plus, I guess, everything's going to stay cool. The transistors stay cool. And the faster it goes, the faster that it switches. I don't know why, but it's like the cooler it gets. It's when it gets hold up and the amps build up there that it gets burnt out.
Hey, everybody. Thanks for dropping in. Like and subscribe. Let us know if you have any questions. This is Papa Bale. We're working with Pulse Motors today, doing some experiments.
Heck yeah, the experiments.
Boom.
And this 9 magnet rotor has ceramic bearing.
And mostly we're looking at RPMs and input voltage.
And this one's actually got a tack strip, so we'll be able to get a nice even reading on it. Instead of having to divide by 9.
Mm-hmm.
It's going to sit a little bit lower. I see it's on already, the little one. There we go. That's what it was. Backed out too far.
Hey everybody, thank you for the likes. Need one more to get up to 10. Let's do this. Appreciate you guys.
Thank you. I think that it was backed out too far. But now it's good. Now it's working right, I think.
It's not every day you see intelligent content on YouTube Live. Appreciate that. Oh, Society of High Science has cracked a good one. Should try sneaking that bad puppy on an airplane.
In the on-board bag.
Yeah.
Yeah. Along with one of these, like a ghetto Tesla coil.
A ghetto Tesla coil.
And then just have like your red sunglasses on, and you're like, you got this serious, most serious look on your face. You're like, yeah, that's my science experiment. You're not smiling like I am right now. You're like all serious.
Mm-hmm. Got to do it with a straight face.
Yes.
Now he's like, LOL, yes.
But when they're taking you away in cuffs.
And lots of assorted colored wires.
Yes, yes. Just like you see here. You can do it at home, folks. Just like you see here.
Oh.
Is it the red wire or the blue wire?
Well, it depends on which one you grab to set the circuit up. Yeah. Boom. In other words.
And was the guy who set it up colorblind or not?
Ooh. Ooh. Check it
Please
out.
like and subscribe. I don't know. Would it matter? You get your greens and your reds screwed up.
All right, let's see if I can say this right. What's up, Lolo Loqui?
What's up?
Loqui. Yeah.
Hello.
The colorblind guy has the highest amount of luck, though.
Yeah, that's so true.
Mm-hmm.
Making everybody jelly. You know, such good luck.
Isn't Zuckerberg colorblind?
So this is going pretty slow. Pretty slow. We'll get the tack out where to put it in my pocket. Good Lord.
Right in front.
Thanks, homie.
Mm-hmm.
With my head wasn't attached.
This is
512.
Pulse Motors, and we're hanging with Papa Bale. We're doing RPM readings, voltage readings, and air gap readings, the distance between the coils and the rotor. Each one of these has square cubed neodymium magnets in them. That has 9. How many's in here?
2.
2 in this one.
We were just working with 3 earlier.
And then these are the inputs. And we're testing RPMs today.
So 530 now. 541. So it's going up now that I moved the coil in. Let's move this one in a little bit.
What in the Inspector Gadget is going on here? I like that one.
I almost fell for that. I almost went go gadget. And then
yeah.
I didn't do it. I didn't do it.
Good. This is for fun. We are doing experiments DIY style for fun.
Go gadget. What? Well, that's why I didn't do it.
What type of machines would these be used in? Well, you know,
This is you'd have to scale it. You'd
yeah,
have to scale it.
depending on the scalability and the size. You know, you can converge it with anything that would work with these kinds of circuits. Just think about it. Appreciate it, Lolo.
But I would say mainly toys. The toy industry would have great use for stuff like this. Like a top, like a dreidel, a little dreidel top that could spin for days. You know, I mean, that would be fun.
People are like, I want it in my home, my vehicle, my boat. I want to train with this.
I want a tattoo of it on my. Never mind.
I want to be able to take it camping and be off grid with all kinds of power. It's like, yeah, we're working with a couple watts here. Cause
Now, like, if I was gonna make a generator of usable energy, I might go serpentine, coil, maybe 3 serpentine coils in a 120-degree configuration. We'll do a standard AC 3-phase generator. We'll put, see, this is the 2 right here. You just flip one of them around and you have a north-south. And you can use this rotor as a 3-phase generator rotor because it's 180 degrees. You got north here, south here, and then you can either position them directly on 120 and use radial coils. Wow. Okay. Or you can use the serpentine coils like I suggested and wrap them around a core. 120-degree pi. Like if you do the outer of 120 degrees instead of the inner. So basically that'd be 120 degrees at 8 inches diameter instead of 6 inches for the rotor. But yeah.
right about 10 more minutes.
Okay. So I would definitely use this one for a 3-phase generator. I mean, if you were going to hook it up to something, you would want 3-phase electricity. Any way you want to generate that 3-phase electricity is A-okay with me. Normally, you would have the magnet be on the shaft, the shaft go through the magnet, and then the shaft would spin as well. But you don't have to do it that way.
You've done it that way before.
Yeah.
Check out the channel, like and subscribe. It's in there.
Yeah.
Rotating
I got
shaft.
playlists to help navigate through some of the stuff. Not every video's on a playlist though. I'll work on fixing that. So 500 readjustment after, and I'm just happy that's working on. Working on 6. Let's see if it'll work on 12. Nice. The amp draws really low still on this coil. That's awesome. Getting some arcing now. Some arcage. And we're getting some nice charge on the battery. And the idea is to get the charge to equal what we're spending, or at least really close to it, to prolong the experience. Alright, and so, yeah, we're going to utilize the cap bank, AC to DC cap banks. You know, actually, I'm thinking you might not use the cap banks. But I don't know. We'll see. I'll have to do it both ways. See if we can even get it to run without the cap banks.
Yanni wants an oscilloscope. He's
Oscilloscope?
just been winging it. The pulse is similar to phases. Pure smooth sine wave is normal. Square is not. Good learning anyway. Cheers.
I don't have the oscilloscope hooked up currently. But I do now. I'm curious. How many minutes we got? Like 2?
7.
7? Alright, we're gonna hook it up. Got me curious. So we're going to hook it up to the end of the trifilar strand to get a AC reading, strong AC reading.
Work mode.
Boom. Alright, let's turn it on. I should get a little reading just from the other coil being on.
Zoom in there.
So it's a nice sine wave. It's just really, really small. Bless you.
Oops, sorry.
Alright, let me turn it on now. So it is a square wave, sine wave type deal here.
Thank you for the like. We got the 10 likes. Appreciate you guys.
Thank you.
Rock and roll.
Oh, look at that. Okay. Gotta shrink it now. Alright, that is an AC-DC spike, or an AC spike, top and bottom. Alright, let's go with time.
Yanni, he's drooling. Sorry, Yanni. He wants it.
So it's a bunch of little square waves on a sine wave. So it's a bunch of little square waves riding a sine wave, but they're all the same height, so that's pretty freaking awesome.
Yes. Yeah, that is a. I don't. There we go.
And I didn't even know this one had an oscilloscope until it came in the mail. And it was the same one that 3D PPM was using, and he I just watched that video that he made, and I knew how to use it. So I was like, yeah.
Yeah, YouTube. I learned how to do stuff on YouTube. Yes. I do not watch TikTok though.
So that's awesome. We're up to 1270 on the battery. Wow, man, everything's just going up right now. But I think in order to cancel out the effect of these two circuits being different and me not being able to change that is using a cap bank on each one of them. So using two cap banks to nullify the differences in the two circuits. One's SSG, one's SSG gen mode, and I can't change that.
So what makes the screw switch thingy oscillate?
Screw switch thing? Oh, this is hooked up to the output of this SSG right here. And the magnet, when it passes by, completes the circuit. When it passes the screw, the copper connects to the copper, and well, bam, you get motion. So it's got power. It's not a battery. It's the SSG output, which it's being used as a battery right now. But yeah, so I mean, from peak to peak on the sine wave here is virtually 28.8 volts.
What size?
What size? What?
Yeah, what size what, Daniel?
Rotor?
He may be on a different time. Yeah, what size rotor?
All right, this is a 6-inch rotor, and this is an 8-inch rotor. This one's got 9 magnets in it and a ceramic bearing. And this one's got 2 magnets in it and a steel bearing. This one weighs about 3.5 pounds. It's heavy. And this one weighs about 1.5 pounds. It's pretty heavy too, because it's small.
Thank you for the like. Voltage. He had 6 on both inputs. And he just shut this one off, but it was at 6.
Excuse me. I'm going to shut this one down.
Input voltage. And they're charging batteries, so.
But that oscilloscope reading was coming off the trifilar strand of this coil. So it was coming off of transformer like style stuff here.
All right. Hold that for you.
All right, so I'm going to switch this rotor with the 3 magnet rotor. Yeah, it weighs like 3.5 pounds, man. That's pretty heavy. There we go. And yeah, I'm gonna get ready to run a relay. I don't know if this will work. This is not a way that I was told that it would work. But that's what we're doing. So thank you very much, ladies and gentlemen. Peace out. Have a wonderful day. And we'll get back to you later. Bye now.